So now I want you to do some similar things with hash sets that we've just done with array lists. So I want you to build up a class of useful non-destructive functions on hash sets and compile it and put it in your class path. So that'll give us, let's go to the right place. So here we have it's the some useful functions, some useful methods. We've got one which called union, which takes two hash sets and returns the union, which is a hash set. And that's very similar to append that we did with lists. So we create a local variable hash set t, which we into which we put a copy of x, the first parameter. We then add all to y, and we return this t that we've the local variable, which will now contain the union of x and y. The important thing is it's non-destructive. The parameters x and y will have the same value before that they had originally before we call union. So similarly, intersection, that's exactly the same, except instead of add all, we use retain all. So you should check add all and retain all in hash set to see what they do. Now another useful one is the set difference between x and y. The set difference, we call that minus. The set difference between x and y are all the elements of x that aren't in y. And I do that with a loop. I say, so again I start off with t being an empty hash set. This time we start off t as an empty hash set. Here we set it to start it off with x. Here we start it to be empty, and we iterate through every element of x and check whether it's in y or not. If it is in y, then it's not in the difference between x and y. So we add it to t if it's not in y, if not y dot contains o. In other words, if this object o isn't in the set y. So we return, so t will be all the elements of x which aren't in y, and that's what we return, and that's what the difference between two sets is, minus. So now to use that, to test it out, we've got this class called testset.java. So let's have a look at that. So here we're assigning t, we're making t to be the set 1 hello and u to be the set 1 goodbye. We're printing out the union of t and u, the intersection of t and u. We're trying t minus u and u minus t. So the union should give us 1 hello and goodbye. The union should give us 1 hello and goodbye. The intersection should just give us 1. T minus u, that's the things that are in t that aren't in u, well that should just be hello. And the things that are in u but not in t, that should just be goodbye. And notice that where we call these methods, because they're in a class called sets, and sets is in our class path. We say sets.union, and then we put in actual parameters for the formal parameters of these different methods. So let's see what happens when we run this. So we run it by saying Java test set. And there, as we expected, we have the union is hello 1 goodbye. The intersection is just 1. T minus u is hello, and u minus t is goodbye. So again, we can compose these things as we had before. So let's try. Let's try another one. So let's have sets dot minus So in other words, that's the things that are in T but aren't in the union of T and U. So if an element's in T but it's not in T or U, well, there's nothing in there. So this last one here should give us the empty set. So let's compile that and see if the last thing that prints out is the empty set. So I've got to recompile that now. So that's test set.java. Now if again we compile it, and here the last thing we have is the empty set. So the nice thing about defining these non-destructive methods like union, intersection and minus is we can compose them all together almost like mathematical expressions. So this is like saying T minus T union U, and we can make these expressions get as complicated as we want. Good. So the next thing I'm going to talk about is how to do your easy assignment.